Team Geothermal Vision from the University of North Dakota, in partnership with Iceland School of Energy, is assessing the feasibility of a combined geothermal heat and power plant for Newtown, North Dakota.
Geothermal energy originates from hot rocks in the Earth's subsurface. It is typically brought to the surface with water or steam from a hot aquifer, which is circulated through the community and into homes before being re-injected back into the aquifer to prevent reservoir depletion. In addition to heating homes and buildings, a district heating system can be used to melt snow from streets and sidewalks, as well as provide heat for greenhouses. Geothermal energy is renewable, sustainable, clean, available 24 hours a day, 365 days a year.
Newtown, North Dakota is located in the western portion of the state of North Dakota on the Fort Berthold Indian Reservation, home to the Mandan, Hidatsa, and Arikara Nation. One of the reasons why we've chosen to assess Newtown for a potential geothermal project is that it is centrally located in the prime of the Williston Basin and has ample wells that have previously been drilled, giving extensive geologic information and information about the subsurface. Here you can see many of the wells that have been drilled in and around Newtown, North Dakota. Many of these wells are targeting very familiar formations such as the Bakken Shale or other oil and gas bearing formations that have made the Williston Basin famous. However, in this project, we will be targeting the Cambrian Ordovician Deadwood Formation, which is located just above the Precambrian basement in gray. Here, we strip away the other formations that are irrelevant to this geothermal project, and instead focus on the Cambrian Ordovician Deadwood Formation, shown in red, orange, and yellow, just above the gray Precambrian basement that is supplying the heat for our geothermal system. We also keep the purple layer, the Bakken, in so that you can get a familiarization with what the ground is like below your feet and what the geology is like under Newtown. As we move down the hole from Newtown, shown as a red dot on the map, you can see that although it is a sedimentary basin, the Cambrian Ordovician Deadwood Formation is more or less laterally continuous throughout the basin, meaning that there is not much differentiation in the layer itself at that depth below Newtown. As we zoom in here closer, you can see that the Deadwood Formation is actually made up of three members, titled the F member, E, and the D member. For this geothermal project, we will be targeting the top layer of the Deadwood Formation, member F, because this formation shows the greatest signs of high porosity and high permeability that will make our geothermal system possible, meaning that there's enough space for fluid to be stored in the geothermal reservoir and brought to the surface. As we move to the surface of our system, the red dot on the map marks our proposed geothermal combined heat and power plant. This will consist of a production and injector well spaced approximately 500 meters apart, as well as an organic Rankine cycle power plant that will supply both heat and power to the distribution system shown in green. This heat system will supply the community of Newtown, shown as yellow dots on the map, with clean, cheap, and sustainable heat.
Although the initial investment is high, return will exceed investment well before the end of the expected lifespan of this project. Federal grants and low-interest loans are available to help fund this project. The projected cost of geothermal fuel is less than the cost of propane. Heat resource depletion can be avoided with close reservoir management. Aside from land disturbance during the construction of the network, there are few environmental